So in the last video we saw how to configure static NAT, and in this example we are going to understand dynamic NAT, and then later the last one, PAT, which is called the port address translation. So in dynamic NAT what happens is that we do not configure one-to-one mapping, but we configure many-to-many mapping. So what I mean to say is, if you see this diagram, we take a list of private IP addresses and we map them to a pool of public IP addresses. Now the trick here is to conserve public IP addresses is that we take a larger number of private IP addresses, we take a bigger list of private IP addresses, and we uh, map that to a comparatively smaller pool of public IP addresses. As you can see in this diagram, we are using around 254 private IP addresses and we are mapping them to around 50 public IP addresses only. So 1:5. So for every 5 private IP addresses, we are just having a single public IP address. So the trick here, what NetRouter does, is that it knows not everyone is constantly using internet. So whenever you send a request to receive a web page or any other FTP file or something from internet, that time it will assign you an IP address, first come first serve basis. So there is no hardcore one-to-one mapping here. You will reach to the net router, and net router will assign you the IP address or translates your source IP address with the public IP address which is available at that time, and it will send the packet to the internet. And what if there are no public IP addresses available right now? Then your request will be kept into the buffer for a timeout, and if some public IP address gets free before the timeout, you will get to go to the internet. So at best you might see a slight delay in your internet access, but still you will be able to get there. Having said that, if there are some certain applications which are constantly using the IP address, then it might create a problem. So it's not a best solution, but it will somehow work if your company's internet access requirements are somewhat moderate. So let's see how to configure it. We are going to use the exactly same concept. We are going to create a list of 254 private IP addresses, out of which I will show you the example with 3: 10.0.0.1, 10.0.0.2 and 10.0.0.3, router 1, router 2, router 3. And for a public pool, we are actually going to use, as I showed you, the public pool of 201.0.0.11 to 201.0.0.16, and we will see first come first serve basis these IP addresses will be assigned to different routers. Let's go ahead and configure the net router. So this is a 3-step procedure. First step is to assign the interfaces inside and outside. Second step is to create a list of access control list and a pool of a list of private IP addresses and a pool of public IP addresses, I beg your pardon. And the last part is to map them, correct? So we can say it's actually 4 steps. So let me write it down here. So first step we are going to do is to configure interfaces, and that will be inside and outside. Second step will be to create a list of private IP addresses. Third step would be to create a pool of public IPs, and the last and final step is to map the list to pool. That's what we are going to do. So let's start with the very first part on the net router. So right now I'm on the network address translation router, and I'm going to assign the inside interface with the command ipnet inside, and the interface facing to the internet with the command ipnet outside. So that's pretty similar to the static NAT step. Now the second part is to list all the private IP addresses which are candidate to be translated. So we create an access control list for the list. So pretty straightforward. Access list. It can be a standard access list. Access list 1 permit 10.0.0.0.0.0.255. So sorry, it's too many E's. Let me fix that quickly. Alright, so you can see that access list 1, which includes all the addresses starting from 10.0.0.0 to 10.0.0.255. That means all the usable IP addresses between 10.0.0.1 to 254. And then this is the second step. Third step is to create a pool of public IP addresses. So we use the command ipnet pool for that purpose. And you need to specify a name for this pool. So let's say the name is capital pool 1. And then inside the pool we create the range of public IP addresses by putting the first IP address and the last IP address of the range. So 201.0.0.11 to 201.0.0.60 as we are thinking. So just 50 IP addresses here. And after this you can use the keyword prefix length or the net mask. So let me show you the prefix length. You can just put the number of bits into the subnet mask, and if you use the keyword net mask, you have to put the whole subnet mask in its traditional format. So let's just use the keyword prefix length, and the prefix length I want to use is 24. It's a class C network. So that's it. We have created the a private IP address list and a public IP address pool. So let's do the last thing, which is to map them. So this is going to be IPNet inside, and this time the source is going to be the list 1, which we are going to map to pool 1. Excuse me. That's it. That's your dynamic mapping done. 4 steps, as I said earlier. Configure interfaces as the inside and outside, list the private IP addresses with the help of an access list, create a pool of public IP addresses with the command ipnet pool, and map the list to the pool. Now let's go ahead and try to access the internet from router 1, 2 and 3. So I'm going to reshuffle it. I'll start accessing it from router 3, and then I'll go to router 2 and router 1. So they should receive the public IP address 11, 12 and 13 as they go to the internet router. So let me go to the router 3, and from here I will do a telnet to router 2, and let me see if the telnet is configured. Okay, it's there. So took a little time. We specify the password and we are into the internet router. Now if I check show users, you can see I have received the IP address 201.0.0.11, the first IP address available on the net router. Now if I'll go to router 2 and telnet the internet, provide the password, check the show users again. As you can see, the new one, the current telnet session is 201.0.0.12. So you got the idea. We can go to the router 1 and do the telnet as well, and it should go to 201.0.0.13. So yeah, there you go. So you can see it's first come first serve. The IP address which is available will be provided. Now if I go to net router, we can actually see this translation happening. So show IP net translation, and as you can see that 10.0.0.3 is mapped to 201.0.0.11, and to be more specific, it's a telnet connection as a TCP going to the port number 23. So perfect, that's your dynamic net. But as I said, the only problem with dynamic net is that there are limited number of public IP addresses which can be accessed at any point of time. So the better method to configure or to use here would be to use the PAT, port address translation. Now what happens in PAT, it's very interesting. In port address translation, when you receive different requests from different clients or different private IP addresses, they all are mapped to the same public IP address. So you don't need a pool of public IP addresses here. You just need a single public IP address. Mostly it is the exit interface of the net router. As you can see in this diagram, on the right hand side, it's all 201.0.0.2. That's the public IP address or the exit interface IP address of the net router, or the outside IP address of the net router. And the trick here is that for every random request, every different request from the client side, from the private address side, we note what is the IP address and the port number combination, and we map it to our exit interface public IP address and a unique port number of that IP address. Now every IP address has 65,535 ports. Out of these ports, 0 to 1023, these are called the server side ports or well-known port numbers, but 1024 onwards, these are available for the client side requests. So you can see that for different random requests we use the sequential port numbers in the public IP address part. Either that, or in some implementation it can use, or it can imitate the original port number which the client has requested, like 2524, the client side port number. The same we can use here. So remember, this is the client side port number. You are going to the well-known port number 23, but what is your client side port number? That's always random, but the combination of IP and the port number is unique, and that's why that's how the net router tracks for the incoming or return traffic to be sent to the proper internet or internal computer. So this is awesome. That means we can just use a single IP address and we can theoretically address or service almost 64,000 computers. So let's do that. Let's remove the dynamic net, and then we will configure the net overload. So for dynamic net part, or port address translation, what I'm going to do is I'm going to use this 201.0.0.2, and there are only going to be 3 steps for this particular procedure. First step would be to assign interfaces as inside and outside. So this step is same as we did earlier. Second step would be to define a list of private IP addresses which you want to use, so private IPs, right? And third step is to map the list to exit interface of net router, that is 201.0.0.2. Very easy. So let me go ahead and remove the last part of dynamic net which we did, to remove the pool and the mapping. So before that, let me clear these translations. So clear IPNet translation star, and this should actually clear all the translations. And then what I'll do is I'll remove this mapping here, which is associating the list to the pool, right? No IPNet, this. And also I'm going to remove the public pool. So what am I having now is this, an access list which is listing all the private IP addresses. So I already have the interfaces assigned inside and outside, and I have an access list telling me all the private IP addresses. So let me map these private IP addresses, or this list of private IP addresses, to the single public IP address. That is awesome. So let's do that. IPNet inside source is still list 1, but this time instead of mapping it to a pool, we use the command interface, and the interface which is outgoing on net router is fast ethernet 0/1. So we say fast ethernet 0/1, and then a very important keyword, overload. If you don't use the keyword overload, it is not going to use different port numbers of that exit interface, and that would mean you are matching, or you're mapping all the private IP addresses to a single public IP address, and that will be a dynamic NAT with the only one IP address. So that means first come first serve, whoever gets to go to the internet, that will be the lucky one. Nobody else would be able to go outside. So overload keyword is very important. That's why the port address translation is also known as net overload. Makes sense, right? So let's do it now. Let's see if we can go to the internet or to router 2. Let me first disconnect from everywhere, and alright, so let's go to the internet router again. We are there. From other router also, let's do it. Telnet, we are in. From another router, telnet, and we are in, right? If I go to the internet router and check show users, what is interesting here is that these are the old entries, but if you see the newer entries here, 101, 102, 103, they all are coming from 201.0.0.2, right? And if you go to the net router and check show IP net translation, you will see something very interesting happening here, which is that actually some of them, these are old entries as well. So what's happening is that 210.0.0.1 some random port number is mapping to 201.0.0.2, and in this case you can see it's using the same port number as the client is using and going to the destination 2222. So this is awesome. Now we can actually use the same public IP address and different port numbers of that public IP address are being used to get you to the internet. So that is called port address translation. It allows you to use a single public IP address for virtually any number of private IP addresses you have. The only limitation you have is the hardware limitation or the capability of your NAT router and your bandwidth bottleneck, of course. So thank you very much for watching this video, and please don't forget to like and comment, and let me know if you need some improvements or some any other kinds of videos. So let me know in the comment box. Thank you very much.